But this isn't just another robot. Protoclone Vion is packed with over 1,000 artificial muscles, a full human-like skeleton, and more than 500 sensors acting like a nervous system. It doesn't use motors. It moves with fluid pressure just like real muscle tissue. It even has a cooling system that works like sweating, a detail that makes this robot feel less like a machine and more like a biological organism. It can twist, kick, and flex with over 200 degrees of freedom, and while it can't walk yet, it's built to learn from humans, do chores, and adapt in real time. No face, no voice, just raw, lifelike movement. Clone Robotics says this thing will one day live in homes, make food, do laundry, and more, essentially becoming a mechanical assistant designed to fit into human routines. This is a robot built to move and maybe think like a human. Now, Clone Robotics is a Polish-American startup. You might remember them from a few years back when they showed off this freakishly realistic robotic hand. That was just the beginning. Fast forward to today, and they've built a full-body android dubbed the Protoclone V1. It's got a full musculoskeletal system with a skeleton modeled after a real human body. We're talking about all 206 bones, and all joints are fully articulated. That means it's designed to bend, twist, and flex just like us. The skeleton itself is made from a high-strength polymer, three-dimensional printed with structural reinforcements that allow both flexibility and durability. But how do these artificial muscles work? It's based on something called the mimicking muscle concept. Each muscle is a mesh tube with a balloon inside. When hydraulic fluid gets pumped into the balloon, it expands and forces the mesh to contract lengthwise, imitating biological contraction. These are called myofiber actuators, and they're what give Protoclone its strength and fluidity. What makes them powerful is that they behave similarly to real muscles, not just in motion, but in how they distribute force. When they contract, they don't jerk or snap, they pull smoothly, distributing tension across artificial tendons and joints the way real muscle groups do. And because these actuators are modular, they can be repaired or upgraded individually, making maintenance more efficient. And it's not just about strength, it's about control. Every joint and muscle is monitored by over 500 sensors, including inertial sensors, pressure sensors, and depth cameras in the skull. This setup works like a synthetic nervous system. Inertial sensors detect motion and orientation, kind of like how our inner ear maintains balance. Pressure sensors track exactly how much force is being used, crucial for delicate tasks like grabbing an egg, and the depth cameras allow Protoclone to understand its surroundings in 3 dimensions, much like human vision with depth perception. All of this is processed in real time using a decentralized control architecture, allowing different limbs and muscle groups to respond to their environments semi-independently. Now let's talk degrees of freedom, because this is where Protoclone outpaces most other bots. Standard humanoid robots have about 50 degrees of freedom, meaning 50 ways to rotate or articulate joints. Protoclone, over 200 degrees. That's a massive leap, and it's obvious when the robot moves. In demo videos, it's hanging in a support rig, can't walk yet, but its limbs twist and jerk in ways that are unnervingly lifelike, not clean or digital, more like a person jolting awake from a bad dream. These extra degrees of freedom are made possible by a layered joint system that allows overlapping movement ranges, similar to how muscle groups coordinate in biological limbs. Some people find it creepy, its faceless head and twitching limbs hit that uncanny nerve. Clone Robotics knows this, that's why there are no facial features. Instead, Protoclone V1 wears a flat black visor where the face would be. This serves 2 purposes. It avoids the uncanny valley effect that unsettles people, and it makes room for packed-in sensors without worrying about human-like eye placement. The visor is made of a transparent composite that hides the internal cameras, but allows them to see out, combining function with aesthetic minimalism. This is all part of a bigger plan. Clone Robotics wants Protoclone to learn by watching, not just by being programmed. They're working on a telekinesis-style training platform, meaning people can teach the robot by performing tasks it can observe and copy in real time. Their goal? Full household help. They claim it'll eventually be able to make sandwiches, fold laundry, pour drinks, vacuum the floor, you name it. Sounds futuristic, but they're not joking. They envision a world where robots like Protoclone could be as common in homes as smartphones are today. And if you want one, don't hold your breath. The first version, called Clone Alpha, will be a limited run of 279 units. No pricing yet, but don't expect a bargain. With this much advanced tech and innovation, it won't come cheap. Each unit is expected to include custom training support, direct firmware updates, and cloud access for remote learning and updates, hinting at a long-term ecosystem rather than a one-time sale. The systems inside Protoclone are just as impressive. The myofiber actuators are filled with fluid that pumps in and out, making them contract and relax like actual muscle tissue. That fluid moves with speed and accuracy, powered by a 500-watt electric pump. It pushes fluid at 40 standard liters per minute and up to 100 pounds per square inch of pressure, enough to mimic real biomechanical loads. Think of it as the robot's heart and bloodstream, always circulating to drive movement. It also doubles as a cooling system. This design not only improves efficiency, but reduces energy consumption, making it more sustainable for long-term use. Protoclone sweats, not literally, but water flows through micro channels in its frame to cool the muscles. These channels release heat from the myofibers when they're working hard. Without it, they'd overheat, lose efficiency, and eventually break down. The way this fluid system is routed mimics blood flow, absorbing and releasing heat as needed. Clone Robotics didn't just copy our shape, they're copying how we work on the inside. The system also includes thermal sensors that monitor heat levels in real time and adjust fluid flow dynamically. Sound was another big design factor. Pneumatic systems are loud, over 86 decibels, like a lawnmower. But Protoclone's pump runs at just 36 decibels. That's quieter than a normal conversation. And they did it without adding insulation. Instead, they shaped the fluid paths and pump chambers to reduce air turbulence and vibration, the main causes of noise. If this robot is going to live in your house, it needs to sound like a housemate, not a power tool. It's one of those invisible design wins that makes the tech feel more personal. But here's the thing, it still can't walk. Every public demo shows Protoclone hanging or supported in some way. That's because walking on two legs is incredibly complex. The balance corrections humans make while walking are instant. Pneumatic systems just aren't fast enough yet. Clone Robotics knows this, and they're planning to switch to hydraulics for future models. Hydraulics react quicker and carry more consistent pressure, which is key to two-legged balance. It's not just about strength, it's about syncing hundreds of parts in real time. Walking is a full-body coordination problem, not just a leg movement issue. The company is calling Protoclone the world's first bipedal android with a musculoskeletal system. Technically, there's been something similar. Kangoro, a robot made by Japan's JSK lab back in the year 2017. Kangoro could do push-ups and had its own internal cooling system. But it was built for research. Protoclone is built for homes. That's the difference. One is an experiment in movement, the other is meant to be part of your daily life. Going from lab to living room is a big leap. Most companies, Boston Dynamics, Tesla, Figure AI, are sticking to electric motors, stiff frames, and pre-planned motion paths. Clone Robotics is doing something completely different, building bots that move like we do, from the bones up. Their design philosophy is rooted in biology. Every design choice seems to ask, how would nature solve this, and then builds around that answer. Even the joints prove it. They reinforced weak points in the skeleton so it won't wear out under pressure. And the motion? It's smooth and natural, not mechanical. In the newest videos, the limbs flex and resist like a real person getting up after a hard workout. There's inertia, recoil, and subtle shape, all the micro movements that make something feel alive. Online reactions have been all over the place. Some people are hyped, others are creeped out. One person asked them to draw a smiley face on the visor. Another joked that sci-fi warnings are now tech blueprints. Either way, people are watching, and that tells you something. Even the skeptics can't look away. Because under the unsettling exterior, this robot is something new. Clone Robotics has built a machine that doesn't just look human, it's designed to act human. Every component, from the artificial muscles to the cooling channels, is built to echo biology. It's bold, it's weird, and it works. So here's the question. Do you think a robot with muscles, bones, and nerves should be living in your home? Or is Protoclone crossing a line we're not ready for? If you want to keep up with the latest in humanoid robotics, make sure to hit like, subscribe, and turn on notifications. Thanks for watching, and I'll see you in the next one.